So let me just review the question that we're on right now. Concentration of a drug in a person's bloodstream is modeled by an equation. It gives you the equation. And this equation is based on time. The concentration is related to the time. So the concentration is the dependent variable, and time is the independent variable. Time is measured in hours, and what we have here is the first derivative that we are trying to get. But why are we doing that? Let me sort of review with you why we're doing that. By the way, let me just make sure I can see the chat here. Yeah, why are we doing that? Because the question was asking over what interval of time is the concentration increasing? And I think one of you correctly said, well, why would the derivative, when we got the derivative, we're trying to figure out why would the derivative help us to figure out where it's increasing? We didn't ask you where the concentration was equal to zero. We're not asking about when the rate is zero. That's what we normally use this derivative for. But we're asking for where the concentration is increasing. And then I know somebody did say that it probably would be when the derivative is positive. And that person's actually right, because a positive derivative means that the slope of the function is positive, because that's what derivatives tell us. Derivatives tell us the slope. And if the slope is positive, that means the original function is going up. That's exactly what it means. So if we can figure out where the derivative is positive, right, where it's greater than zero, that's what positive means, then that will tell us the interval of time where the concentration is increasing, right? That's what we said when we did this. Okay, so let's get back to the question. So we now had to find the c prime of t, the derivative of this function with respect to time. So we did that. The top derived multiplied by the bottom using the quotient law here, minus the bottom derived multiplied by the top. There we go. And that's all over the denominator squared, right? So then we multiplied out the first one, 24x squared plus 48x plus 408. You helped me out with that part. But here's a part that we have something missing. Can anybody see what's missing here? Right? Let me just move across here a little bit. Right? We multiplied these two things together and we got this. So what's missing, folks? Right? And I know we're rushing, so that's probably why we missed it. But what's missing from that bracket? When we multiply those two things together, there's something missing. Can anybody see what that is? Come on, folks, look at it. You tell me. Nobody sees what's missing? Silence in the court. I don't want silence. I actually wanted somebody to say something. Another 48x, you're saying. Absolutely. Right. So the 24 times the 2x times the 24 gives us a 48x squared. That's fine. The 2x times the 24 gives us a 48x, but we have another 2 times 24 to give us another 48x. So let's just erase that. And let's now put in, let me grab my stylus here. Let's put in that other 48x. Okay, why is that still there? Hang on, let me get rid of that. There we go. That should be another 48x. And then we should have the 2 times the 24, which is plus just 48. Okay, let me extend that line. So we did make that mistake on Friday. So let's keep going from there now. See if I have enough room down here. Let me just fold this thing over. So now we can try to put all our stuff together here, right? Let's put everything together. So it's 24x squared, right, minus 48x squared. So I'm thinking, by the way, okay, you know what? Before I do that, let me just minus this second bracket here, because I think that's probably, I don't want to put too many steps in one. So 24x squared, that's a 2. Doesn't look like it was a 2. Plus 48x plus 408 minus 48x squared. Now, if you put those two 48x's together, of course, we're going to get minus 96x. Right? You can double check that in your head there. Remember, I'm minusing everything inside the bracket and then minus that last 48 on the end. Right? Remember, everything in the bracket gets minused. And that's over that denominator of x squared plus 2x plus 17 all squared. Okay, now let's try to tidy up the top. I'm seeing a 24x squared and a minus 48x squared, so I'm thinking that's a minus 24x squared. And I'm seeing a 48x and a minus 48x. Sorry, 48x minus 96x, and I'm thinking that's probably minus 48x. Double check that on me for me, please. And then I'm going to have 408 minus 48, which I believe is plus 360. And all of that is over the denominator that we had before. So x squared plus 2x plus 17 all squared. So the question is asked, the question we're asking is for this derivative, right? Our original question was, where is it increasing? And I said that it's increasing wherever this thing that we're getting is greater than 0. Now, let me remind you, for it to be greater than 0, it must mean that when you take the ratio of the top and the bottom, so it's a fraction. So if it's a fraction, the only way for this to be positive is if both the top and the bottom are negative, right? Which means the whole thing is positive, or the top and the bottom are positive. Let's just be clear on that, right? You can only get a positive from a fraction, from a quotient, if the top and the bottom are both negative, or the top and the bottom are both positive. Can I sort of make sure everybody sees or understands what I just said, right? It's a fraction, that must be the case. Thank you, Kushi, and thank you. Okay, great. Now, here's the thing. The bottom of this, and we said this on Friday, is always going to be positive, right? There is no way for the denominator to be positive, so to be negative, because it's a square. So that means that we really should only be focusing on the numerator and asking, when is the numerator positive? That's the answer to the question, right? Where is the numerator positive? So how do I answer that question? I can ignore the denominator because the denominator is always going to be positive. So whether this fraction that we have is going to be positive or negative is going to depend on whether the top is positive or negative. So let's treat this, go back to your work with polynomials in advanced functions. Really what we're asking is this: where is minus 24x squared minus 48x plus 360, where is this greater than 0? Not greater than or equal to 0, by the way. Let me just be clear on that, right? If you're equal to 0, it means that you are not positive, you are 0, right? That's different. We're asking for where it's positive. And positive means that it can be equal to 0. 0 is not positive. 0 is neither positive nor negative. So this has to be positive. So think back to advanced functions for a bit. How do I answer this question? How do I figure out where that quadratic, that is a quadratic, factor it out and solve the inequality? Okay, so we'll do that. We'll do that. We'll factor out. In fact, what can we factor out right now, Kushi and anybody else? What can we factor out right now? We can factor out the minus 24, so we'll do that. So minus 24, and then what we have inside would be x squared plus 2x. And I believe that would be, what is that, 360, I don't know, what is that, 15, I think? Thank you. So minus 15 is greater than 0. Okay, so we factored that. Where do we go next? What happens next? What happens next, folks? That doesn't answer, we haven't answered the question yet. All right, where is this thing greater than 0? Solve the inequality? How, Taj? Yeah, fine, but how? Tell me how to solve it. Let's see, you sketch it. The thing in the bracket is greater than 0. True, that's true. But where's it greater than? See what Sarah just said? We need to sketch it. We need to draw it. That's exactly what we need to do. We need to draw this thing, right? We need to draw it. So how do we draw it? And I don't mean run to Desmos, because the whole idea is that you don't have Desmos to work with. Please understand that if this was you sitting in front of me, I would not allow you to use Desmos. So if you're not using Desmos, what do? How do you sketch it, as Sarah just said? And she's right. I mean, how do you, the question is, how do you do that? How do I know what this thing looks like? All right, 24, sorry, minus 24, x squared plus 2x minus 15. How do we know what this looks like? Find the zeros. Thank you, Tomaleo. Okay, so let's do that. And you do that, of course, by factoring it. And what are the factors in this case? Right, so Tomaleo is right. We have to factor it. So how do we do that? So you're saying x plus 5 and x minus 3. Okay, so we'll do that. Right, so yeah, we can confirm that when you multiply those two things together, you get the minus 15. When you add them up, you get the plus 2. So that's true. Okay, but now we have to sketch it. Right, Kushi and Adam are both right. 5 and minus 3. Perfect. But now we have to sketch it. What does this graph look like? Roughly speaking, don't have Desmos. All you're working with is what you're looking at in front of you. What does it look like? Okay, Sarah is now saying she's here. Let me just put her in as being here. Just give me 1 second, please. Okay. Thank you for letting me know, Sarah. It is x at minus 5 and 3. Okay, let's do a little sketch here. So minus 5 is over here, and 3 is somewhere over here. It's not drawn to scale, folks, so please don't give me a hard time over that. All right, so yes, we got that. But what does it look like? What does this graph look like? It's a quadratic. What does it look like? Opens down because of the negative. Thank you very much. So I'm going to see if I can draw that with a different... Oh, I didn't mean to put snow in there, folks. I'm sorry. It's snowing for the next 10 seconds. That was not intentional. I hit the wrong one. Sorry. All right, it's actually snowing outside, I think, anyway, so what the heck. Anyway, let me get to the color palette here and change it to red so we can sketch the graph. All right, so Adam says it opens down, so I'm going to think it looks something like that. All right, festive. That's right. That's right, like Christmas in, what is this, February. All right, let me go back to my black. Okay, so there's my graph. So now, let me remind you what the question was. The question was, where is it increasing? We said that as long as the graph was positive, right? As long as, sorry, not the graph, as long as the derivative is positive, greater than 0, positive, then that means that the original function was increasing, right? So now we have the picture, right? Adam says it was opens down, right? And he's right. And the zeros we were told were at minus 5 and positive 3. So we've got that. So now we have a picture. What's the answer to the question? Hall pass, Alexander says. Okay, Alexander. Now, what is the answer to the question? Where is this graph positive? Anybody? Where is it positive? From where to where is it positive? Between minus 5 and 3. Thank you very much. Thank you, Kushi, who's been very active today. Excellent. So between minus 5 and 3 is where the graph is positive. So let's do this. Let's put a round bracket here and another round bracket on the other side. I remind you that when you were learning this in advanced functions, the round brackets meant that the minus 5 and the 3 were not included. Okay, but let's look back at what we're talking about here. We're talking about, so these are t values, right? These are t values. So anywhere between minus 5 and 3, this derivative that we came up with is greater than 0. It's above the x-axis. And I remind you again that we're only focusing on the numerator, because once the numerator is positive, we've already accepted that the denominator is always going to be positive because it's squared. So since the denominator is always positive, then the numerator, when it is positive, makes a whole fraction positive. I want to repeat that. Okay, now remember that the t in this case is measuring hours. So does this range over which the t is above the x-axis for the derivative Does that apply to this case? What do you think, folks? Should I say that it's from the time from t equals minus 5 up to t equals 3? Adam says 0 to 3. Sarah says no. Adam says no. And why is Adam saying only 0 to 3? Why does that sort of restrict us? Why is he restricting us down to that? And why is Sarah agreeing with him on that, right? What is it that is constraining us in this case? Help me out here, folks. Adam says it's only from 0 to 3. Why? Why not go from minus 5 to 3? Negative time. Yeah, we don't have negative time. Well, not in I'm certainly not aware of it anyway. I'm sure that those who believe in, strange, the theories of whatever that you saw in like the Matrix might think that this is the case. But for our practical purposes, time is only measured starting at 0, right? It has to be positive. So the answer to the question is that and I'm going to answer the question this way. The function is increasing, or the concentration is increasing, and I use the upward arrow as a shortcut for increasing, from t, when t is greater than 0. All right, let's do it this way. Let me change this actually, because I want to make sure we don't include the 0 and we don't include the 3. So let's do this. Less than 3, greater than 0 seconds. I think it was seconds. Hang on. Hours. Okay, so the last question on the problem set is this guy right here. An object is moving along a horizontal straight line. Distance of the object from the origin at any time can be modeled by the function, and to give you a cubic function. That's the cubic function, where t is in minutes and d is in centimeters. Okay. So when is the object stationary? Now remember, this function is a distance function. This is not a velocity function, it's a distance function, right? What the d in this function tells you is how far you are from the start. That's all it tells you. All right, so if I wanted to know how far I was at 5 seconds, I put 5 into the function for t, and it will tell me whatever that d is, that's how far I am from the start. So when it's asking me for when it is stationary, how would I approach that exactly? How would I approach it to figure out where it is stationary? Folks, I'm expecting a little bit of reaction from you. When velocity is equal to 0. Thank you, Javier. And this function that we have is not a velocity function, but something we learned earlier on is that if you take the derivative of the position function, you have the velocity function. So we'll do exactly that. Let me fold this thing back over, and let's find the derivative of this function. So the d prime of t should be equal to 6t squared minus 66t plus 168. Right? That represents our velocity function. So the d prime of t, which is the first derivative, and I'm saying first derivative because our next class is going to be talking about second derivatives and so on. But our first derivative of this function is 6t squared minus 66t plus 168, and this first derivative function will tell you velocity. So now what Javier is saying is we want this velocity, that's your velocity function right there, to be equal to 0. Because at that point, your velocity is 0. Because this is your velocity function. So let's set this equal to 0. So we're taking the 6t squared minus 66t plus 168 and setting it equal to 0. And you know how this works. How do I solve this equation at this point? Right? What do I need to do to solve this equation? We set it equal to 0. It's a quadratic. So just like we did in the last question, how do we solve for t. We factor it. So this is factorable, I think I remember correctly. So this is 6t squared minus 11t plus, what is that now? 6 into, what is that? What is the 168 divided by 6? Help me out here. 28, thank you, plus 28 equals 0. So we can factor that some more. And I'm thinking t, they're both minus 7 and minus 4. Okay, thank you. Thank you, by the way, Kushi and Sarah. So now we have an answer, right? There are 2 points at which the 2 times at which the velocity is 0. So when t equals 7 and 4, and both of these are in minutes, but no, what is this in? Sorry. T's in minutes, yes. These are both in minutes. So at those 2 times, the object is stationary. All right, it's not moving. Okay, so we've answered that question fine. What is the object station? When is it moving away? Okay, well, I know what to think about this some more. When is it moving away from the origin? And when is it moving towards the origin? How are we going to answer that? It is stationary when the function, the position function obviously has a 0 slope. You can go back and look at that and you can see for yourself. Okay, so there you go. Between 4 and 7 is when it is moving towards. When it is moving away is between 0 to 4, and then from 7 onwards. Okay, exactly what we said it would do.